No, it's just going to continue to build, and you're going to continue to know it better.
But I don't know it at all.
So, when we were doing range and domain and all the before, we're going to continue to do domain a lot. We're going to continue to work with functions a lot. You can see quadratic functions and models. You did that already, and you're going to do that again. So, next. So, today we are going to write things in vertex form. You don't need that. Don't write that. Okay, you don't need this either. This is review. Okay, if it's a review, you don't need it. Okay, this is an intro. So in this section, you will be studying graphs of polynomials. You have already been introduced to linear throughout your math career, yes? Yeah. And constant. And we have done some quadratic, or they call it the squaring function. We have done some of that. We're going to do a lot more with that and writing it into vertex form. These are all polynomial functions. Now, in the textbook, if you read yesterday, do not write that top definition. I want to explain it to you, and I really don't think you need it, okay? A polynomial function just means a function with terms, and if there's more than one term, it is written in descending order of one variable and ascending order of another. So, it just says let n be a non-negative integer and has all these integers of real numbers. Look at my function. I have a coefficient, I have an x to the n. And then a coefficient, another coefficient, and x to the n minus 1. So that means descending order. Okay, you knew that. Does that definition make that look completely crazy? Yeah. Uh-huh. And all it is saying x to the third, x to the second, x to the first, x to the 0. That's all it is. A polynomial function is just a linking of terms. And a polynomial function could be also just a constant as well. Okay, what we're going to deal with in this section are a degree of 2. So you have constant as a degree of 0. A linear is a degree of 1. Now, a lot of people do great with the degree of 1 because I'm like, okay, what is the exponent on that x? And you can tell me 1, right? Because we know if there's a 1 there, if there's nothing there. But when I say a constant has a degree of 0, they're like, huh? I don't get it. So let's write it as a constant x to the 0. What is anything to the 0 power? It's 1. Okay? And every standardized test you have is going to test that out that you know that.
1 or like
1. Anything
it's always
to this
number 1.
Always number 1. And the reason for that, when I have exponential functions, okay, x to the first, x to the 0, x to the 28 is an exponential function, yes? It means multiply the base by itself that many times. That's what it means. So if I have 2 to the third, that means I take 2 times 2 times 2. So I get 2, 4, 8, right? But if I started with 0 and 2 to the 0 was 0, would I ever get to 2 to the first? Think about it. If I had 2 to the 0 and it equaled 0, could I ever get 2 to the first? Because 2 to the first is 2 to the 0 times 2. Yes? Yeah. Could I ever get to 2? No. So anything, no matter what it is, if it is to the 0 power, it is what? 1. And if you don't know that, you should like star, big print, whatever on your paper. Because if I gave you some obnoxious polynomial and you're going, and put a 0 behind it, what is it? 1.
So with the star, you want us to feel like no matter what?
Anything to the 0 power is 1. That is like one of the main things you should have got about exponential functions when you did exponent rules.
Can all of our homework questions be to the 0th power?
No.
Dang.
Shucks.
Will there be some?
No.
Dang it.
Not in here. Not in this one.
Thank you.
Okay, but that is a base, guys. I bet on the ACT there was at least one question that had a 0 in there somewhere that could have made it just 1. And what the options were 1, 0, and then 2 other things. And people guessed what most people picked. What'd you guys say?
Probably
0. And it's not.
Big
It's
number.
1. Okay, so second degree is known as a quadratic, and you know that, yes? We've done that. This is not new. What we're doing today is not brand new. We're just using it in a different way. We've already done it in chapter 1. We've already done what we're doing today in chapter 1. We're reinforcing, but in chapter 1 we did it with absolute values and square roots and cubic. Today we're doing it with quadratic. That's it.
You have to write any of that down.
The 0, you might want to know that if you don't know, the quadratic would be x squared, but it's also here. So things usually happen again. If they happen twice, I'm probably making sure I write them down, right? Okay, each of the following are examples of quadratic functions. I don't know if you want to write these down or not, or just look at them. Why are they all? What power are quadratic functions?
Squared.
Second, squared, and that's the biggest one, yes? And that's how we say polynomials. We name them by the biggest power that occurs. So you have constant, which would be 0, right? Linear is 1, quadratic is what? 2. Cubic is 3, quartic 4, and then after that, well, quintic is 5, but we usually don't say that. Anything after 6, you just say 6-degree polynomial, 7-degree polynomial, 8-degree polynomial. Typically, people start that with 5th because quintic is kind of weird. Quartic makes sense, right? It's quarter, quartic. But these are all examples of, you see a square here, you see a square here, here. I don't see a square here.
But x times x.
But x times x, when I FOIL, is x squared. This would be x squared plus 1x minus 2x, so that would be minus x minus 2. Some of you need to work on that because on the test I'm going to tell you people did not multiply that outright. They multiplied the outside and the inside, and that was it. FOIL means first, outer, inner, last, or distribute means give it to everybody. If I was to give you half of you candy, would the rest of you be really mad?
Actually, yeah.
Yeah. So you need to share. Okay? Now this box, anything that's in a box is a direct mathematical definition. If it doesn't make sense to you, don't write it down. Am I clear there?
Yeah.
If the words on the screen do not make sense to you, do not write exactly what they are. Write what makes sense. Typically when you read the textbook, they'll have a nice box, and then right underneath it, they're going to say it in plain English. So sometimes if you look at the box and it doesn't make sense, then look at what? Right underneath it, and it's going to explain to you what it is. You guys are learning to learn from a textbook right now because you are going to have to do that in your future careers of whatever subject you take. You're going to have to know how to learn from the textbook that you have in your hand.
You're subbing for Winchester.
Yes, I am. Okay, so the definition of quadratic function is A, B, C. You have seen A squared plus B squared equals C squared before in your life. Have you not?
No.
Yes, you have. When you were introduced to quadratic functions in Algebra 1, that's what they told you. That is called a quadratic function because the highest degree is what? 2. That's it. Okay? A cannot be 0 because if A is 0, that first term is 0, and I no longer have a quadratic, I have a what?
1.
I have a 1, which is a what kind of equation? Starts with an L. First
Linear.
degree linear. Okay? So if A is 0, I don't have a quadratic, I have a linear.
Why?
Because if A was 0, the first term you'd be only left with bx plus c, which is the same as y
Oh.
equals mx plus b, yes?
Yeah.
Okay, so if A is 0, you don't have quadratic, you have linear. That's all these conditions are, guys. These definitions are really confusing, but you just have to break them down. I can tell you still to this day when I take classes to teach dual credit, I read those definitions and go, what? And then I have to go through and break down each part of it and say, oh, that's all this means, okay? So math speak is pretty specific, and sometimes we lose what we have. Okay, what is the shape of a quadratic function when we graph it? What's the name of it? A parabola. Did you know that? Yes, that's what this thing says. I don't want to hear horseshoe from you anymore, right? It's a parabola. When I say parabola, you should think of something that looks like a horseshoe, correct? Okay, they are symmetric. Do you see these? They're symmetric through the vertex. Did you know that? Yeah, see? You knew all this stuff. All parabolas are symmetric with respect to the x-axis, the axis of symmetry, which goes to the vertex. That's it. Okay? The leading coefficient on this first one right here was it positive or negative? Because it opens up.
Positive.
Positive. Okay? That A was positive. Did we discuss that last chapter? To an extent, a huge extent, yes? Okay? What's the leading coefficient of this one?
Negative.
Negative. Right here. And that's all that says. So on my paper, I'd probably say negative A, or you could say A is less than 0. Oops. Let me write it on the right one. Could I write A is less than 0 and just put a picture like that?
Yeah.
Okay, what's A is less than 0 mean? The coefficient is negative. Okay? And this one over here, I could just write A is what? Greater than 0. What I'm trying to do here, guys, is teach you how to take efficient notes, because we are not taking efficient notes in here, are we? We spend a lot of our time writing things down that maybe it's too much, because notes are supposed to be useful to go back to, because if they're as long as the textbook, why not just open the textbook, correct? The other thing is if we are a slow note taker, I really do want to encourage you to leave a space and then go back and rewatch the video to write it down so we can get to examples in class rather than writing information down. Would that be cool? I think so. Okay, so all of this is review, yes? A is positive, it opens what direction? Top, up. A is negative, it opens down. This is an even function. We discussed that a little bit last chapter. What does even mean the ends are going to do?
They're gonna end at the same.
They're going to end at the same place, yes? Okay, so quadratic functions are even functions because they start and stop in the same direction. Okay, we will do algebraically what it means to be even. If it's an even function algebraically, if you plug in a negative x, every time there's an x, when you're done simplifying, it just comes out to be x. Does that sound familiar? Maybe proving things were inverses, right? So a lot of stuff. So this is just the same repeating. This coefficient A was greater than 0 because it's opening what direction? Up. Okay. And my vertex is what on the graph?
0.
Yes, but like what part of the graph? The vertex, the axis of symmetry. It's what's at the bottom of a graph? Minimum. If it opens up, the vertex is going to always be a minimum. If it opens down, the vertex is always going to be a maximum. And again, see how they wrote it? They wrote A is less than 0, and they wrote A is greater than 0.
You have to do that?
What do you mean? I'm just showing you they wrote it the same way I did on the last slide. Now, when this says the leading coefficient, that is the leading coefficient when it's written in order. Make sure it's written in order. What's the correct order to write a polynomial? Descending order. So that highest degree goes first, right? There's a trick question on the test. Could you just tell me what it was? Just give you a huge hint.
A trick question.
Yep. On the next test, there will be a trick question. Anybody? I picked it up. I just said it. You have to pick it
I
up.
can't remember what you
Other
just
than
said.
But what were we just talking about?
Descending order.
Descending order, and that's the degree of it, the polynomial.
So it's not going to
right?
be in descending order.
It's not going to be in descending
Ooh,
order.
okay.
Wow.
Just give me the test.
Yeah,
now.
can I write that
I'm ready.
Let's go.
Okay.
I was gonna write it in my notes.
No. Okay, so if it's going up, we have a minimum. If it's going down, we have a maximum. This is not hard stuff, is it?
It's gonna get hard.
Okay, so now here's another reminder. Okay, if I have that 1/3 should not be there. It should be here. This should be an x. Okay, f of x equals 1/3 of x squared.
Less than
Can you
0.
rewrite that?
Less than 1.
Rewrite what?
It's f
I'm
of x.
confused.
F of
equals
x.
1/3.
I moved it around. This is f of x equals 1/3 x squared. It was when I moved the pictures around and made them bigger. The 1/3 they don't connect them if I'm using somebody else's.
I couldn't see.
Okay. Better,
Well, it's just because like it was
right? But better though. Okay. So this, remember our rule. If the absolute value of a was greater than 0 but less than 1, what does the graph do?
It's
Yes.
gonna be
very-
wider.
It's wider. Here's x squared. Here's 1/3 x. So we're just using the things we've already learned in greater detail. Okay? Now I have g of x is 2x squared. Well, we have the absolute value of a was greater than 1. What did the graph do? Get
Narrow.
narrower. So it gets wider here. And then wider than what?
The parent.
The parent function.
How do you know what A is? Sorry.
You don't the whatever a is, it's the leading coefficient. Because it's a x squared plus bx plus c.
So how do you know if A is less
Well,
or greater than 0 and less than 1?
it's the number. Like,
There's
3.
going to be a real number.
yeah, it's gonna be a real. It's not gonna be just a. Or you're gonna have to calculate. Today you're gonna have to calculate it. Yes.
Okay, so you put like the absolute value like lines
Mhm.
maybe like with A.
Yes.
So if there was a negative,
The negative just tells me where it opens up or down.
okay.
That's
so,
it. Because remember we walked through that vertex
Okay.
form before,
Yeah.
and that negative just tells me up or down. That's it.
So like if it was negative 2x squared,
Mm-hmm.
would it turn to a positive 2 because in between the absolute?
Yes.
Okay.
So in negative 2 would be exactly the same, but reflected.
Why
Yeah.
does, I'm confusing myself.
Yeah. So just take a breath. Just take a breath. Everyone good? Because we haven't even got to using it yet. So we're just reviewing what we already know. Okay, and then for instance, the figures below, notice how the graph of x squared can move. Okay? Now, don't look at the picture, look at this right here. What does this negative tell me?
It
Yeah,
was
really
less
nice.
x.
Okay, so it opens down, right?
Uh-huh.
What's this tell me?
It goes up 1 unit.
Okay, what goes up 1 unit?
The vertex.
The vertex. So 0, 0 goes to 0, 1. Yes?
Yeah.
Is that what happened?
Mhm.
Yes. Okay. So this one. The A is positive, yes.
Yeah.
What is the A?
1.
1. Okay, so that's not doing anything, so it's going to open what direction?
Up.
Up, up.
It'll go left
to-
2.
Left 2.
Up 3. Well, down 3.
So it's going to go left 2 and down 3. So the vertex is going to be at -2, -3. Is that
So
what
how
happened?
would you get the negative 2?
Because vertex form, this is what?
X
Minus h. So the form is minus. So if it's a positive, a negative times a negative is a what? Positive. That's how it became positive. All reviewing it, right? Okay. So standard form, also known as what form did we call it?
Vertex.
Vertex form. And why is it called vertex form?
It
Because
calculates
you're
the
changing the
vertex.
vertex.
Because what is the vertex?
H and K will become your vertex.
H and K will be your new vertex. So if you don't know that, which some of you don't, because of what I just graded last night, you need to write it down. But I promised you everything I would do in here, I would show you the vertex form. Did I do that?
Yeah.
Yes. And I will continue to do that on every single function I introduce to you. I will show you the vertex form. I promise. So we're going to be looking for, and I would probably add a plus and a minus up here. What does that plus and minus do?
Change it, it opens up or down.
Opens up or down. Okay? So the plus or minus, whether it opens up or down, the A, what does it do?
It decides whether if it's wide or narrow.
Right, it's the rate of change. And yes, but we can't say slope because it is a constant.
No.
No, and the rate of change decides whether that is wider or narrower. So plus or minus reflected over what? What axis?
X and Y.
Not y,
Y.
just x.
Wait, why?
Why
is
not
it-
Y?
Where's the y at if it happens?
It's
On the x. But with a parabola, does it matter reflecting over the y?
No.
No, we just move it left or right to take care of that reflection. We don't like reflections over Y's, they're gross.
Okay.
Okay, so what's A do?
Rate of change.
Is my rate of change.
So
And
like-
again, I put absolute value, correct? Okay, so if the absolute value is between 0 and 1, the graph is what?
wider.
Wider. And if the absolute value of A is greater than 1, it is what?
Narrower.
Narrower.
Can you take
Okay, what's H?
It's your. It goes horizontal.
Yep, because H stands for left or right, or H stands for horizontal left or right. So it's right or left. And what's K?
Up or down.
Up or down. And together, HK is your what?
Vertex.
Vertex. It is your new vertex, right? Because the other one was at 0, 0. H is actually your axis of symmetry, wouldn't it be?
Yeah.
Because your parabola, this is HK, and this is your axis of symmetry. So your H is also your axis of symmetry. So you guys already knew a lot of stuff. Ish. Well, hopefully it's less ish-ish.
Not yet.
Not yet? Okay, so all of these things did exactly the same today as they did last week and the week before and the week before, the last 5 weeks, correct? It is never going to change. So should you start applying this to your permanent memory?
Yeah.
Yes. It's not going to change. Guys, I will not teach you something that's conditional. That is such a wrong way to do it. Because if I teach you something that's conditional, are you going to have to remember a new condition next time and a new condition the next time? And that's horrible. I hate shortcuts because they don't apply all the time. Am I good, Maddie?
Mm-hmm.
So, it says write the equation in standard form, vertex form. I think the book always uses standard form, but what is standard form? Vertex form. Okay, it has a vertex of 2 and 3, and it goes through a point of 0, 2. So what is my vertex form? Y equals what?
Positive, negative.
Positive.
A.
A,
X minus H.
X minus H, and we're what? Quadratic, plus K. So, I have, what things did they give me?
Vertex.
They gave me a vertex, so that is a what? H and a K. So on my paper, I would write my vertex and write H and K right under it or above it. What else did they give me?
X and Y.
An X and a Y. So they gave me an X and a Y. So if I look at this formula, I have a Y, an X, an H, and a K. I don't have a what?
A.
I don't have an A, but can I find it if I have all the rest of those things?
Yeah.
Yes, so what do I have to do?
You have to plug it in.
I have to plug it in. Have we done that before?
Yeah, I think so.
Yep. Okay, so I have 2. So Y is 2 equals A. And don't worry about the plus or minus because the math will make the plus or minus happen. Okay? And then X minus H squared plus K. So 2 equals, oh yes, plus 3. Thank you. I just put plus K. Because in my brain I should be saying plus K, but K needs to be what? 3. Thank you. Okay, so 0 minus 2 is what? Negative 2 squared is? 4. Okay, be careful because I will tell you what not to do that I've seen many, 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 many times repeatedly.
I was about to add 4.
You people put 4 plus 3 and tell me that's A plus 7.
No.
Yeah, don't do that. Don't do that.
gonna get us all shot collars, and if you do that,
I
then
know.
we're just and up the wall.
Oh, squaring quantities, do you know how bad I wanted to have those, like last night when I was grading? I wanted to like, okay, now what?
We're like laying in our bed and we get
Subtract
Subtract 3, okay, so I get -1 equals 4a,
And then divide.
and divide by 4.
Yep.
So a equals -1/4. So I have an a,
Yeah.
I have an h and a k. Can I write this in standard vertex form?
Yeah.
Yes.
Yes. So it's going to be y equals what?
-1/4 parentheses x minus 2 plus 3
Squared.
plus squared.
Squared plus 3. That is the biggest thing people forget when they do this is the function.
So you just don't put the x and y in there?
No, because now I have an equation that I can graph the whole thing, yes? If I would put the x and y in, I get 1 point, and that's it. I want something that's useful to graph the whole parabola.
Okay. I kind of understood that.
Okay? Do it again.
I don't know how you graph it.
I didn't ask you to graph, did I?
I know, but
I didn't ask you to graph, did I?
no.
Focus on what I asked you to do. Okay. Write the equation in vertex form, or standard form, that has the vertex of -2, -2, and goes through the point -1, 0. I would like you to attempt to do this on your own.
Yeah. So
No one talk.
Yeah.
Shh, that means you too. Keep working. I'm just working it out. So if, as you get done, you can check. Maybe I missed it. No, you're square. It's not square.
So that's what
What about Maddie? Square is too square. How'd it go, Gentry? Did you get that?
I think.
What do you mean you think?
did your answer look like that one?
Oh, that. I wasn't even checking it.
Yeah.
Okay, but why is the 2 in the parentheses positive?
Why is the 2? Connor, can you help her out?
Because it starts out negative in the regular one,
Oh.
and then -2 and some negative in the
Right. The formula starts out negative, and I'm placing in a -2. So a negative times a negative is a what?
Positive.
Positive. Yes.
I switched to 0 and then positive 2.
Oh, don't do that. Okay. Did you label when you wrote down your points? Did you label exactly what they were? Maybe that would help you.
Probably help.
Okay. Biggest mistake I see, guys, and I see it in your homework. You're not writing the problem on the paper. Okay? So in this problem, there's 2 things I need to get, right? 2 points. And I can remember 1 point at a time. So I go to the book and I get 1 point, and I go back to the book and get another point, but I got it from the problem number like 30, and when I was on problem 15. Is that going to help me out? No. Write the problem on your paper. It doesn't take that long. And then make sure you wrote it right. Then do it. Because if I don't write the correct problem down, am I going to get the correct answer? No. Even if I do the right steps, I'm not going to get the correct answer. Evan, do you have a question?
Yeah, like the -1 + 2 in the parentheses. Where'd that go? It just like disappeared.
Well, it's 1 and 1 squared is 1. So it didn't disappear. It's in front of the A.
Oh, okay.
Correct?
Yeah, my bad.
Can we do another one?
I have another one just in a different form, okay?
Oh,
So I do have another one.
we can get the one form that
Yeah.
No, it's just what?
a new one.
What? What did I give you?
Oh, it's that?
He gave us that.
I gave you
wait.
Okay, I gave you a vertex and a point, correct?
Yeah.
Is it any different?
No.
No, that's what I need you guys to get. Just because it looks different, you're going to do the same stuff. You're going to write on your paper what?
H and K.
You're going to write 1, 2, and put a what above it?
H, K,
H and a K. And you're going to write on your paper what?
3, -6.
3 and -6.
X and Y.
And X and Y. And this is actually easier because I know my A better come out to be what? Negative. And the other ones I didn't know that, did I?
I
Okay,
didn't know that.
because it's pointing down.
Oh.
It's opening down. But don't let the math show you. The math should give you a negative A.
I have to grab it first, otherwise I'm gonna look back on my notes and get confused.
Why? You didn't grab the other one.
I'm not even
Like-
writing these problems down, I'm just working them out. Like I'm writing them.
I think we're fine. I'll come sneeze on you in a minute just to make you feel better. We shouldn't do that. That's not nice. Going a little faster?
No.
No?
I'm trying to figure it
Okay.
out.
No, don't look up here then.
No, I'm just checking step by step.
Okay. Like, don't
So,
look up
because
here.
I don't
I
want to
always
do
forget
it
to
and
put
then
my-
have the wrong number somewhere and then I get.
That's okay. It's okay to do it and get the wrong number because then you can fix the mistake that you're doing.
Always forget to do
This is like the one thing
Maddie
I
got
know
it.
how to do it.
Maddie got it.
Still trying.
Her light bulb turned on. The back of the room's brighter. Okay, when you do this, it helps you write your equation easier and not make a mistake of putting your X and your Y in for your H and your K. If you label them. Does that make sense what I'm saying?
How do you get -8?
How did I get -8? I subtracted 2.
Oh.
Even when I actually understand this.
Wait.
Okay?
There's gonna be a
I just don't know when to add them.
See coming to hit us.
I just solved the equation just like we did in 8th grade math. Algebra 2. Algebra 2. Algebra 1. Geometry. Algebra 2. Just solved the same equation we've been solving for several years. Questions?
No.
I got one more
Is this
example
it?
for today. One more, I think. Oh, wait.
Oh.
Shoot. I do have one more example today.
Like these?
Kinda. I think I do.
It makes me feel good about myself.
I think
not
this
feel
is my
that.
favorite example of the whole day. I like this one. Really gets you
But
to
if you
think.
get like this and
If y equals -2.
it feels really satisfying when you get
X minus
I think
This is my favorite
we
example.
should end here.
No, I don't have one
It
more
really- it
example.
really gets you thinking.
I don't have one more example because 47 through 50, I want you to use what you know. Because you know how to do those problems, and I don't want to do an example. I want to see how you do them. Okay, so your assignment on the board is different from yesterday. I reevaluate. If you wrote it down yesterday, it is different, or you took a picture of it yesterday, it is different. Okay? Today we are writing equations. Tomorrow we're going to be writing more equations, but we'll be sketching these graphs. But just sketching them, right?
It's 47 through 50 what we just did.
No, 47 through 50 I did not do an example of.
So,
Is
and
everything
then like,
else what we just
it kind of like what we did?
We have done it before. Everything on there we have done before 47 through 50, but it is